So this is sequences and series now, eh? 2.1 says, given the quadratic sequence, okay, so this is a quadratic sequence. They give you the first four terms. And 2.1.1 says, write down the values of the next two terms of the sequence. Okay, so you just have to continue with the sequence, eh? So let's try. So let's quickly figure out what's happening here. So to get from here to here, they minus 31. Then to get from here to here, they minus 29. Then to get from here to here, they minus 27. So if you look at the pattern, so do you notice that we are going down by 2 every time, eh? 31, then it's 29, then it's 27. So that means the next one is going to go down by negative 25. So then I'm just going to say, what's this? Minus 25. So I'm going to say 234 minus 25. And I get 209. And then 209 minus. So now negative, I'm going to minus 23 now. Okay, so do you see the pattern there? So 209 minus 23 will give me 186. And that is the next two terms, eh? So that's how you will get 2 marks over there. So 1 for this, 1 for that. The next question is determine the general term of the sequence. So the general term, and here they give you the standard form for the general term, eh? So let's do that. So 2.1.2, this one is also easy. So I write my pattern down. So the pattern they gave me. Then I'm first going to do the first difference, eh? So the first difference, so I'm going to say this minus this gives me this number over there. So that number over there is negative 31. And then I say this minus this. And that will give me negative 29. And then this minus this will give me negative 27. And then I continue to the second difference. So now I say this minus this. So don't make a mistake, eh? It's that number minus this number. This number is negative 31. You put it in your calculator like that, eh? So don't make mistakes with your signs. And your answer is 2. And then you say negative 27 minus negative 29. And there you would also get 2. So you have a constant second difference, eh? And so let's go. We're going to say 2a is equal to this number. And 3a plus b is equal to this number. And then a plus b plus c is equal to that number. So let's go. So I'm going to go 2a is equal to 2. Divide both sides by 2 and I get my a to be 1. Okay, and then I say 3a plus b is equal to negative 31. But a is 1. I solved for a. So now I'm going to put the a in here. And I'm going to solve for b. This is still 3, negative 31. b is negative 31 and then minus 3. So I get my b to be negative 34. Okay, and then I do the last part, this part over there. A plus b plus c. So a plus b plus c is equal to 321. But remember, a was 1 and b was minus 34 plus c is 321. So c is 321 minus 1 plus 34. So I get my c to be 354. So the general term, Tn, is 1n squared minus 34n plus 354. So this invisible one comes from this negative 34 comes from this, and this 354 comes from this. Okay, so how do we get marks? This is a 4-mark question. So this, if you got to the constant second difference, that's a mark. Then working out A, B, and C, and that's how you get 4 marks. Okay, the next question says, which term or terms of the sequence will have a value of 74? Okay, so which term is equal to 74, eh? So I'm going to take my general term and make it equal to 74. So I take my general term that I just worked out, and I make this equal to 74. And then I'm going to solve for n. So standard form. So I bring everything over. So negative 74. So I can make this equal to 0. And then I add my like terms. This is 280. Okay. And again, you can use the quadratic formula or you can factorize. So n is equal to, you copy your quadratic formula. A is 1. B is negative 34. And C, after the standard form, is 280. So then you must show that how you substitute, eh? And then you should get your n to be 14 or 20. Okay, both are whole numbers and both are positive. So that's why the question said, which terms? So there are two terms that will be equal to 74. Term 14 and term 20. Okay, how do we mark? So here we take the general term equal to 74, that's a mark. Then putting everything in standard form was a mark. And then for your final answers, you had to have 2 answers, eh? And that's how you get 4 marks. So 2.1.4 says, which term in the sequence has the least value? So which term will have the smallest value? So if this is a parabola, if it's a smiley, then they want to know, they actually want to know the x value of the turning point. So which term, eh? They didn't ask what the smallest value is because that would be the y value of the turning point. So the x value of the turning point, there's 2 ways to do it, eh? Least value or highest value or minimum or maximum, we can derive. So I'm going to derive, eh? So I'm going to take my general term. So let's write the general term as f of n, eh? As a function. So the general term was that minus 34n and plus 354. So then I'm going to derive in terms of n. So this is 2n minus 34. And then after you derive, you make it equal to 0 to get the turning point. And then solve for n. Take the 34 over, divide by 2. I get n to be 17. So the x value here of my turning point is 17. So term 17 will have the smallest value, eh? It's the turning point. So if you don't want to derive, I'm going to show you another way. So to get the turning point of a parabola, remember a quadratic function is a parabola, eh? So to get the turning point, we normally say x is equal to minus b over 2a. That's how you get the x value of the turning point. Now, our standard form, let's write it down again. It was this and this. So now to get that x value of the turning point, it's minus b, so 34 over 2a. 2a is 1. So this is a positive 34 now over 2. And this also gives me 17. So term 17 will have the lowest or the least value. 2.2 says, given the geometric series. Okay, so that's a tip. They give us the series. So this plus this plus this plus more terms is equal to k. So that's given. And the question is, determine the value of k if the series has 21 terms. Okay, this plus this is equal to k. You see I said plus. So that means we're going to use the sum formula. Now, we have to use the correct formula. Eh? So here's your formula page. Eh? I want to show you. When you look at the formula page, you see this SN is the sum formulas. Eh? So this one over here, this is for arithmetic. And this one over here, this is for geometric. So because this is a geometric pattern, I'm going to use this formula. Eh? So step number 1, copy the formula. So I'm going to copy the formula. And now it says here that the sum of this series is equal to k. So this sum over here, this is k. So I'm going to make this k. Remember, a refers to the first term in the sequence. So a is the first term. So this is the first term, 5 over 8. So this is 5 over 8. And then r, this r is the constant ratio. So how do we get the constant ratio? We say term 2 over term 1. So term 2 is 5 over 16. And this is over 5 over 8. So the answer we get, the answer is a half. Eh? So our r is a half. So this is a half. In brackets to the n. N is the number of terms. Eh? So it says here that our series has 21 terms. So to the 21 minus 1, close the bracket, over r minus 1. Okay, and now we have to solve for k. Now, to solve for k, we just have to put all of this in the calculator, just like that. Eh? So just remember all your brackets. You should get 1,2499. That is your answer. And if we round off to 2 decimal places, we get 1,25. K is 1,25. And that's how you get that answer over there. Let's mark. So if you worked out your R, that is a mark. Then if you use the correct formula and you substitute it, that's a mark. And then for your final answer, that is a mark. So remember, when you read your instructions, it always says round off to 2 decimal places unless stated otherwise. So that's why we round it off here. Okay, so let's go to the next question. The next question says, determine the largest value of n. So we are going to solve for n, for which Tn is greater than that fraction. So Tn, not Sn. So Tn refers to the general term. Okay? The general term of a geometric pattern. So if you look here at Tn, formula page, this is arithmetic. And this is geometric. So let's write this down quickly. Tn is greater than 5 over 8192. So now, do you see this Tn over here? I'm going to replace it with a formula. This formula over there is a times r to the n minus 1. And this is greater than 5 over 8192. Okay, so now I'm going to substitute. Remember, a is the first term. So a is 5 over 8. R is the constant ratio that we've worked out. It's a half, eh? So now I'm just going to sub everything in and I'm going to leave in. So a is 5 over 8 times r to the n minus 1. And this is greater than this fraction, eh? Okay, now I'm going to solve for n. Now I'm going to do the algebra. So first thing, I want to get rid of this whole thing over here. So to get rid of that, I want to get rid of this. So to get rid of that, I'm going to divide by 5 over 8. But what I do on the left, I must do on the right. So on the left-hand side, I'm left with this. And if you divide that, you are left with this. 1 over 1024. Okay, so that is what I have so far. Then, because I'm solving for n, I need the base numbers to be the same. So it's either you make your base numbers the same or you use logs, eh? So let me try and make the base numbers the same. So on your calculator, I'm just gonna do 1024 equal shift and then fact, I get 2 to the 10. So then here, greater than 1 over, then I do this 2 to the 10. I'm going to write it like that. Then I'm going to write the half as 2 to the negative 1 because that is a half. And then I'm going to bring this 2 up. So this is now 2 to the negative 10. Okay. And then I'm going to remove the bracket. So this times this is negative n. And that times that is plus 1. And the base numbers are the same, so they can disappear. So then I have my n. And then I have my n. And then I change my sign. So n is positive. Then I change the sign. And this is 11. So n is less than 11. So what's the largest number that n can be? Because that's the question, right? The question was, determine the largest value of n. But here it says n is definitely less than 11. So the largest number that n can be is n can be 10. So that's how you can do that question. Or you can use logs. So I'm going to say the log of the base stays the base. And then this will come this side. And the n minus 1 is now on that side. So on your calculator, here's the logs. At the bottom, I'm going to put in a half. And then here, I'm going to put 1 over 1024. I get 10. So now I'm going to have 10 is equal to n minus 1. So n is 10 plus 1. So n is 11. So can you see you get the same answer, but not equal to. That was my mistake. This thing is not equal to. This was not equal to. Okay, let's undo that. So this was greater than. So if you read this, you read it in. If you read to the left, you read in the opposite direction. So you say n is less than 11. So therefore, n is 10 because that's the biggest number n can be. Okay? So that's how you can do it, or you can do it like this on my right-hand side. 3 says, without using a calculator, determine the value of the following, so of this expression. So you will have the sum of something minus the sum of something else. Okay, so sigma notation goes with the sum. Now let's deal with this one first. Let's do this part first. So to get the first term, you sub in this number. So I'm going to take this and I'm going to sub in the first number. So to get term 1, I'm going to sub in 3. So then I get this to be 1 over 1. So my first term is 1 over 1. Then my second term, I'm going to make this the next number. So if the first number was 3, then the next number I'm going to sub is 4. Then I'm going to sub 5, 6, 7, 8, 9 until I get to 10 because 10 is on top here. So if I sub 3 into this, I get 1 over 1. If I sub 4 into this, I get 1 over 2. If I sub 5 into this, I get 1 over 3. Okay? So let's write plus because I'm going to add all of these things. Then when I sub in 6, I get 1 over 4. Plus. Then if I sub in 7, I get 1 over 5. Then I get 1 over 6. Then I get 1 over 7. Then I get 1 over 8. Okay, then I get 1 over 8. So that is the sum of the first expression. Then I'm going to do the same thing now. So I'm going to do it for this expression over here. So, okay, to get the first term, so let's write this down. This one looks like that. I'm going to sub in 3, then 4, then 5, 6, 7, 8, 9, and then 10. Okay? So if I sub in 3, Let's start here. If I sub in 3, I get 1 over 2. If I sub in 4, I get 1 over 3. If I sub in 5, I get 1 over 4. Then if I sub in 6, I get 1 over 5. And so forth, eh? So 1 over 7, 1 over 8, and I will stop at 1 over 9. So now the question is just, what is this whole thing if you add them all up? What is that minus all of this? So you can do all of that on your calculator, even though it says without the use of a calculator. Remember, you are showing all of this and showing all of that. And so the final answer here is 8 over 9. And that's how you do that. So you get 1 mark for expanding, 1 mark, and 1 mark for the answer. That's a 3-mark question. Okay, let's look at question 3.2. So question 3.2 says, a steel pavilion at the sports ground comprises of a series of 12 steps. Okay, so there are 12 steps, of which the first 3 are shown in the diagram below. Okay, so only 3 steps are shown. Yeah, that's step number 1. There's the second step. There's the third step. And it will go up until step 12, eh? Each step is 5 meters wide. Okay, so they showed us here 5 meters wide. Then each step has a rise of a third of a meter. Okay, yeah, so each rise there is a third of a meter. And then it has a tread of 2/3 of a meter. So 2/3, 2/3, 2/3. So this is also 2/3, eh? Okay, and now the question is, the open side, so this open side, this shaded part on the sketch, so this is the open side. On each side of the pavilion, so this open side and this open side that you can't see, it must be covered with metal sheeting. Okay. Calculate the area in meters squared of metal sheeting needed to cover both sides. So we have to calculate the area of the shaded part, eh? Now remember, it goes on up until 12 steps. So we have to calculate the area of all of that and then multiply it by 2 because we're doing this side and that side. So that's the amount of metal sheeting that we will need. We need to work out the area. Okay, so let's go. Let's take away that. Let's start. So this part over here, that's a rectangle, eh? So we have to work out the area of that step number 1, that part here. This part here is a third, and that part here is 2/3 of a meter. So to get the area of the first step, eh, I'm going to say a third times 2/3. Okay, and that will give me 2 over 9. Okay, that's the area of the first step. The area of the second step, so remember this is still 2/3, eh? This is a third, but this is also a third. So now this whole part here, so let me use another color. You see this whole part here? That's now 2/3. So 2/3 times the original 2/3 there. And that gives me 4 over 9. Okay, let's do the next part. So the area of the third step. So the area of the third step, eh, this is a third. But then this is 2/3. So a third plus 2/3 is 1 meter. So this is going to be 1 meter times the original 2/3. So this is 2 over 3. And this answer is 2 over 3. Okay. Now there are 12 steps, eh? So now we need to work out all 12 steps. So can't we just, this is a pattern. Remember, this section is under number pattern. So this is a pattern. So to get from here to here, we added 2 over 9. Then to get from here to here, we added 2 over 9. So we are adding 2 over 9 the whole time. That means this is an arithmetic pattern, eh? So my first term is this. My second term is this. And my third term is the area of that, okay? But I know I'm going to have 12 terms. Okay, so this is term 1, term 2, term 3. So I need to work out what is term 12. So I can work that out manually, or I can just, to work out term 12, I can just say, okay, on my formula page, I have this general term, eh? Can't I just work term 12 out by using this? So I'm going to say, what is term 12? Term 12 is the first term plus 12 minus 1 times the constant difference. Now, the constant difference, we said we are adding 2 over 9 the whole time. So if you put all of that in your calculator, okay, so what I actually need is, I need the sum. So let's write it down. I need the sum of the first 12 terms. That's what I need. Because I need to add up all the areas, eh? So I have the first 3 areas. So I need the sum of the first 12 terms. So on your formula page, you have the sum formula for arithmetic, eh? So the sum formula is n over 2 and then 2a plus n minus 1d, like that. So I need the sum of the first 12 terms. So let's write down n is 12. A is the first term, which was 2 over 9. D was the constant difference, which is also 2 over 9. I just have to sub all of this in. So let's go. So n is 12. 2a, a is 2 over 9, plus 12 minus 1, and d is 2 over 9. All of this in your calculator, and you will get the sum of the first 12 steps to be 52 over 3. Let's call it meters squared, because this is the area, eh? Now remember, we need it for both sides, this side and that side. So we're just going to take this answer and we're going to multiply it by 2. So if you want both sides, the answer is 104 over 3, or you can write it as 34,67 meters squared. And that's how you answer that question, eh?